For our confidence interval and hypothesis test formulas, you're going to see it's almost exactly similar to what we've been doing with proportions. Right? If you remember, for proportions, for a confidence interval, we took a sample proportion and we added and subtracted a certain number of standard errors. For a confidence interval for means, we're going to do the same thing. We're going to take a sample mean, add and subtract a certain number of standard errors. You'll notice one glaring difference between these two formulas. While it has the same structure, you'll notice that there's a T star instead of a Z star. And I'll talk about that in a little bit. But that is what a confidence interval does. Right? A confidence interval takes your sample statistic and then we add and subtract a certain number of standard errors. And then we multiply that by the value of the standard error. And that's exactly what we have here. We have a sample mean. We add and subtract a certain number of standard errors. So this is the number of standard errors. And then this quantity is our standard error. So we're essentially doing all of that for these different confidence intervals. It's just slightly different formulas because we're estimating a different parameter. Same thing with our hypothesis test. For proportions, we took a sample proportion. We saw how different from it was it than a population proportion in terms of standard errors. So our hypothesis test formula takes a sample statistic minus a population parameter, and we look at that distance in terms of standard errors. So all of these kind of formulas that we've been doing so far, they're going to be essentially the same thing conceptually and at their foundation, but just slightly different formulas because we're estimating a different parameter. The one big difference is going to have to do with the distribution that we're using. For some reason, when we estimate a mean, instead of using the normal distribution, probability, and percentages, we're actually going to be using something called a t-distribution. And to be honest, that's kind of weird when you first think about it, right? If we go back to our distribution of our sample means, our central limit theorem says if we take a large enough sample size, the distribution of our sample means becomes normal. However, we're not going to be using a normal distribution. We're actually going to be using what we call a t-distribution instead of a normal distribution. Which is odd, because when we estimated proportions, we used the normal distribution. Our central limit theorem says this follows a normal distribution. Yet for some odd reason, when we estimate a mean, we're going to use a different distribution, something called a t-distribution. Now, a t-distribution will look very similar to a normal distribution. However, it's slightly different. Let's see why we're going to be using a different type of distribution for means that we didn't do for proportions. And then we'll go investigate what this t-distribution is.